Here's the outcome or the summary of the photoelectric effect, what hopefully you figured out by playing around with the simulation. We didn't do part 2 of the lab, but all this was outlined in part 2 if you work through the lab. What we know is when light hits the metal, if the light has enough energy, then an electron is ejected from that metal. It takes that certain amount of threshold energy to eject the electron, and that amount of energy is called the work function. If you wanted to know it, you could get it by figuring out the longest wavelength that doesn't emit an electron, then using Planck's law to figure out the energy associated with that wavelength. If the light has more energy than the work function, then electrons are ejected with kinetic energy. The more energy that light has, the more kinetic energy the electrons get. To build an equation, the kinetic energy of those ejected electrons is literally the mathematical difference between the energy of the light and the work function. Now, when I write it up or when I type it or when I talk about it, I have to add that it's the maximum kinetic energy. The simulation was programmed perfectly that the incoming photons of light always had perfectly efficient collisions with the metal so that electrons were ejected. But sometimes when that light comes in, it doesn't hit cleanly, and so the electrons are ejected, but maybe they don't eject with as much kinetic energy as they could have. Maybe it's a funny collision somehow. So the energy we're going to calculate is always the maximum kinetic energy. It's possible that some electrons got less energy, but no electron will get more energy than the difference between the energy of the light and the work function. This is like if I went into a store with $20 and I bought something that cost $7, the most I would leave the store with is 13. Maybe if I tip the guy or drop some money, I leave with less than 13, but the most I could leave with is the difference between the energy of the light and the work function. Mathematically, the kinetic energy maximum, I'm going to say EK max, no vector hat because it's scalar energy, and it's Planck's equation for the energy of light minus WO is the notation for work function. Often we give light in terms of its wavelength, not its frequency. So we've got the second version of it. EK max is hc over lambda, just that other version of Planck's law. Take away the work function. You can read through this. This is basically what I've said out loud. That's where I'll pause the video. What I'd like you to do is go through those 3 examples. Going through that will help it click. And then there is a third part of the lab that I'd like you to do. It kind of wraps things up nicely, and it goes back to some of those lab skills we worked at way back at the beginning of the quadmester when we did like the pendulum lab and some of those other things. So it's a nice full circle lab, so we are going to keep this third part of the lab, and there is a little check-in to go with it. I might have my check-in numbers wrong, but there is a little check-in for this. I think it's actually 5-3. But that's it for photoelectric effect. If you have any questions about it, shoot me an email, and good luck with the lab and the check-in.